I was informed that we are online. Okay, hello everyone. We are on our webinar. Our today webinar is have name Protection of Sensitive Data in the Cloud with Intel SGX technology. And welcome. My name is Dmitry Karaulov, and I'm pre-sale engineer in G-Core Labs, and I'm responsible for cloud and storage, either from technical and commercial perspective. G-Core Labs is a global web services provider with cutting-edge features and advanced security, which provides services for all modern web needs. CDN, hosting, storage, media platform, security, and cloud. And our company is well known for holding educational webinars with best speakers. Moreover, with Intel participation, it will become an entirely new, outstanding experience. As you know, Intel created software guard extensions to isolate specific application code and data in memory. Intel SGX is designed to be protected from processes running at a higher privilege level, including operating systems, virtual machines, and other functions with administrator privilege. So, what is our plan today? We're going to listen our speakers, their brilliant stories about SGX. After presentation, we will discuss these topics in Fireside Chat with question and answers, and please feel free to ask your question in chat, and you will help me to fulfill our discussion with interesting questions and ideas. So today is going to be a really useful talk here. You can find the full agenda on our site, webinar.gcorelabs.com. And once again, please write your questions in the chat box, which you can see down on your right corner. If you have any emergencies, don't worry. On Friday, tomorrow, we will send you a record of this event. But it's always better to be online. So let's dive in.
Yes, this is my turn
Yeah. Hello, Dr. Marcus. I want to represent you to our listeners. It's Dr. Marcus Lieberecht. Am I right?
Perfect.
With your name? He's Senior Cloud Solution Architect at Intel. Dr. Marcus specializes in cloud computing, data center infrastructure, as well as data center energy optimization, and obtains multiple certification from ITIL version 3 Foundation. So we are ready. Marcus, the stage is yours.
Fantastic. Please. Thank you, Dimitri. And I will share my screen, and I hope you can see the title slide just now. Is that correct? Hope so. If not, please interrupt me. So, good afternoon, everyone, and welcome to my short introductory presentation. As Dimitri said, I'm from Intel. I'm working out of Germany, and I'll just want to give you a short introduction about software guard extensions and confidential computing in general. So, let's have a look at the overall security landscape first. In our connected world, I think everyone is seeing and experiencing the effect of the exponential data growth and the eagerness to create value out of that abundance of data. Therefore, cloud economics, with its associated scalability, availability, and the geographic reach, being the preferred solution to create something out of it. The new architectural paradigm, such as cloud native and agile developments, they create solutions that sometimes even have global planetary scale and thus increase complexity due to the sheer number of solution components involved. From a security perspective, this naturally means that the attack surface grows and risks can become hard to justify, specifically in a context of our global connectedness that again can see brands and liabilities compromised. So in order to deal with this virtuous circle of complexity, several solution trends have become more commonplace recently when it comes to security. Number one is don't consider any storage area or connection confidential. Encrypt everything and utilize zero trust principles in your architectures. That, at the second point, means to build and manage explicit chains of trust instead of implicitly assuming so when isolating workloads and data by roles, for example. And thirdly, all of that, do that in conjunction with regulatory compliance that is actually growing in importance in the coming years and is growing more widespread as well. So cloud computing, as mentioned, is the service delivery paradigm of choice today. However, one particular topic makes it hard to fulfill the potential for cloud computing in an enterprise's digital transformation. The joint responsibility between a CSP, a cloud service provider, and a tenant for the confidentiality, or if you want to call it privacy, of data that is being processed on that remote platform is really hard to realize. Let's mainly look at the provider side here. While cloud service providers do their utmost through certifications and external audits to assure and demonstrate their trustworthiness, even these checks cannot completely ensure freedom of security compromising bugs or rogue staff, for example. Hence, for some workloads in data-sensitive sectors, for example, healthcare or finance, regulation imposes so hard security and privacy constraints on processing that data remotely that it gets virtually impossible to comply. And that problem is touted to only get worse in the coming years. And it really blocks digital transformation, so to speak. So wouldn't it be great to have tools and technologies available that help you to overcome this challenge, that isolates an application on the cloud from privilege escalations in its underlying software stack, be it the operating system or the hypervisor, from misuse of powerful identities, and generally keeps application content confidential from anyone but the actual tenant accessing it? This toolset is called confidential computing and is a fairly recent addition to the cloud paradigm thanks to security technologies rooted in silicon. So to put this into the perspective of Intel's data center security strategy that applies to all of our products, it has traditionally been possible to provide controls to protect a server's platform's configuration and manage it proactively. But the most valuable asset handled by that platform, that is your data if you're the tenant, could only be protected via encryption when it was stored or addressed in memory, or while being transferred over the network. Now, however, we can also encrypt it while it is actively being used, while it's actively being processed by the CPU. This is even more important as applications get more and more compromised via their underlying stacks, so that pure software-based security measures will ultimately have to be enhanced by deeper hardware-related mechanisms. It is here that Intel's technology that implements confidential computing, called software guard extensions, comes into play. This SGX, as you've heard it as well, has been on the market for some time now and is available in our Xeon E single socket entry-level servers. It implements a trusted execution environment in main memory where code and data are transparently kept encrypted and are only unpacked inside the processor at the very last time of execution. Having been researched and hardened in real-world applications, it is now available also on latest generation mainline processors, our third generation Xeon Scalable processor, formerly called Ice Lake. It offers a maximum of 1 terabyte of protected memory for the trusted execution environment, the so-called enclave space, secure enclave space, as we call it, and is supported by a wide variety of runtimes and solutions. Attestation capabilities are built in for a remote tenant to ensure integrity of code and data in the trusted execution environment, in that secure enclave, as well as the underlying platform security posture. And this is a really strong point of SGX that sets it truly apart. So with that confidentiality problem between possible intruders and a CSP's platform out of the way, a tenant can now remotely process their encrypted data without having to expose either clear text or keys to any third party. Privacy of data is assured along the full process by cloud platforms enforced to honor the confidentiality, and by attestation providing the necessary integrity guarantees, for example, for a sensitive model that is being used in AI or machine learning and contains intellectual property. These confidentiality guarantees on the cloud therefore permit to cloudify distributed processes such as multi-party analytics and federated learning setups. And by that, also enable digital transformation of sectors that have so far been blocked from doing so. It is a paradigm that more and more cloud service providers are adopting to serve their customers whenever highly sensitive data needs to be processed, and where G-Core Labs has taken a primary step as one of the first players in this market. It is thus no surprise that a wide coalition of industry players also recognizes the importance that confidential computing can have. Intel has a while ago founded, together with other industry partners, the Confidential Computing Consortium as a branch of the Linux Foundation to further the use of this computing paradigm and to align on usage models that will help confidential computing and its applications be driven forward. Because of its security posture and its maturity, Intel SGX is therefore used in the most demanding industry scenarios. For instance, Germany is a country with very stringent regulations on personal data, even more so when it comes to healthcare data. To make matters even more demanding, Germany's healthcare system is characterized by many different distributed providers of varying size and IT capability. In this environment, several private and public health insurance companies have joined forces to create an environment to exchange electronic patient records, but under the strict governance of the patient. In this system, all records are kept encrypted all the time until the very last moment when a medical practitioner needs to see them and act on them. Patients maintain full data sovereignty by managing the access to the health records through a personal app. In this cloud-scale application, all keys are handled via Intel SGX, as is the process of encrypting or decrypting documents that happens inside a secure enclave provided by SGX. And remote attestation is a key component here that is utilized to create the required point-to-point trust. By this, SGX helps to digitally transform sensitive business processes that would have previously otherwise been kept purely on-prem and single organization only, and therefore really drives digital transformation. And the same is true for other verticals listed here on this slide that have not yet been fully able to realize their digital transformation potential. For example, in financial services, confidential computing gets used to train machine learning models on local partial data and recombine these trained partial models in a trustful way, without having to move sensitive financial data to other institutions away from own premises. Money laundering protection that goes through a whole industry can get achieved by this across institutions and in some cases even across legislations. A similar model is used in federated learning in the healthcare sector to achieve results in federated learning without having to transfer patient records away from hospital premises. Similar principle, other vertical using the same capabilities of confidential computing. Lastly, other sectors that operate across many sites, sometimes geographically spread, or for which data governance needs are sophisticated, they are developing their own use cases. In retail, you can create insights from multiple vendors' loyalty programs, for example, for targeted advertising, without having to expose each participating retailer's actual customer data that is both personal information as well as their most valuable asset, and thus doesn't want to be shared. Lastly, it's not just strictly vertical use cases benefiting from SGX. There are actually a lot of transferable design patterns and infrastructure services possible with SGX. And ecosystem partners have implemented a wide variety of frameworks, from simple to more complex ones, from those that are exposing secure enclaves within their virtualized or containerized infrastructure as a service, to creating secure key vaults and their management in the cloud, to finally full security infrastructures and distributed ledgers based on SGX security management. So whether you're moving code to data or data to the code, or process both remotely, SGX provides the necessary assurances for the protection of privacy and confidentiality in computing. In closing, data and technology sit at the root of a modern business transformation. We all know that. Security must advance hand in hand with this projected virtuous cycle of complexity in order to make it possible. And rooting security solutions in hardware is the best way to help ensure a trusted foundation for this. We are committed to doing that as Intel, to put security first, and have included a number of capabilities in our latest generation, third generation Xeon scalable processor that is actually the key vehicle to drive SGX usage also in the cloud forward. So with that, I would like to close and thank you for your attention, and hope you have a couple of interesting questions as well. Thank you very much.
So thank you very much, Dr. Marcus. It was very insightful speech, and thank you, Intel, for such kind of technology. It's cool. I would also like to remind you not to forget your question in our chat. We'll discuss them during our question and answer session a bit later. Our next speaker, Sept Weiner, a cloud platform department head at G-Core Labs.
Yeah, hello.
Hello. How are you?
Yeah, good. How are you?
Nice. Sept has more than 3 years of experience as cloud product owner and overall more than 12 years in IT. Whoa. Sept will give us an overview about infrastructure services with Intel SGX enabled option and share some insights on the first case studies, including Encryption. Please, Sept, go ahead.
All right, thank you very much, Dmitry. So hello, everyone again. I'm nice to hear you and see you there. So let's discuss about how we implement Intel SGX in our cloud, our partnership, our roadmap as well, and use cases, how our cloud use with Intel SGX as well. But first of all, I would like to share about our services, what we provide in our cloud. So first of all, we provide infrastructure and platform services for our end customers. Like infrastructure services include virtual instances, bare metal instances, and all of these types of instances we provide with Intel SGX, Xeon E processors, and Ice Lake processors also. We provide project management and user management also. We provide the private network and L2 connectivity between virtual instances and bare metal. We provide external block storage, load balancers, placement group if you have the clusters and you would like to set for each virtual machine will be in the separate hypervisors also. We provide the disaster recovery for your application between separate regions. And a lot of other stuff. And also we provide the platform services like AI platform where you can train and deploy your ML models, serving your ML models and integrate to your end application through REST API. We have application marketplace where you can bring the new application per one click in virtual instances in bare metal. And also we have managed Kubernetes, where you can bring the new Kubernetes cluster per one click with auto-scaling and auto-healing. And all our infrastructure certified with PCI DSS certification and ISO certification also. From the management staff, we provide self-service portal, API, a lot of providers like Terraform provider, and we have a lot of locations around the globe in United States, in European Union, Russian CIS regions, in Asia also. And we have the huge plans to expand our locations in the new regions around the globe. But I would like to discuss about the data encryption states. Maybe I think you know about most of them, but today we discuss especially in data in use. So data at rest, when you encrypt your volumes, data in transit when you use HTTPS or TLS and send data between internet, for example, and you use SSL for that. And the last one, data in use. So this is the new state of data, and where we use SGX when your application works with the data in the memory. Yeah, so how you can protect this kind of data. So most customers works with public clouds and the big companies, enterprise companies or SMB companies, and share their sensitive data. But your works in public cloud, so you not trust anyone. Yeah, so you have your own application, you have your data, but your works in the separate and shared hypervisor, Ghost OS, and you install, I don't know, another services, for example, so you cannot trust for operation system, hypervisor, firmware, system management model, or any kind of remote attacks for to your virtual instance or bare metal instance also. So you like to protect this data inside the operation system. So we present for this kind of request option with Intel SGX protection. That means so you can use and you can protect your data in the memory. So you trust your application and you trust for the CPU, for the Intel to encrypt your data inside the operation system. So we provide the several flavors, how I said before, with Intel Xeon E processors. And also we provide the new type of flavors, which will be available very soon with the new latest generation of Intel Xeon scalable processor. So we have the several flavors with a big amount of EPC memory, because if you remember or you already works with Xeon E processors, so EPC memory, it's not a lot of big amount of EPC memory. So with the Intel third generation Xeon scalable processor, so we increase EPC size for each flavors, so it will be available soon, and you can use and expand your memory for any kind of flavors. And also, yeah, we discussed about the virtual instances and about the bare metal, but a lot of customers use the cloud native technologies and the new type of architecture, microservices, and of course, we have a lot of requests from our customers to provide the managed Kubernetes with Intel SGX support. And of course, we close works and collaborate with Intel and Scontain to provide these technologies in our cloud. And of course, any kind of our customers can deploy the worker nodes with SGX flavors, and SGX support will be natively integrated to the Kubernetes cluster automatically. And also, we will provide the managed repository to collect your images and containers, and you can easily deploy per one click to your Kubernetes cluster in our cloud. So how it works, from the bare metal instances, we provide the specific operation system prepared for the SGX support, and you can easily use our bare metal servers with Intel Xeon E processors or the new one, Ice Lake processors also. So we provide the specific operation system, and we will install the Kubernetes cluster with SGX device plugin, and after that, so you can apply and deploy your application inside the Kubernetes, which will be supported with SGX. Also, we provide the virtual instances where we provide the EPC memory inside the virtual instances. So we have deeply integration in our cloud, how to provide this memory inside the virtual instance. But the schema the same. So we installed the managed Kubernetes cluster. It's prepared Kubernetes cluster with SGX device plugin. And after that, so you can easily use any kind of application which support SGX, or you develop this kind of integration. How it's said, so we very close works with our partners, with Intel, first of all, and Scontain, who provide this driver, who provides some developed stuff around the Kubernetes and application which support SGX. And we have the end customer like Agregion, who provides the software as a service for the end customer, where you can distribute your data safely. And of course, our plans to provide this managed Kubernetes with SGX support this year, I would say so we very close works with our partners, and I hope so we will present this type of functionality this year. Also, we will provide another platform services like function as a service, centralized login system, managed MQ, and all of other stuff, which will be also supported very close with SGX. And our main task to provide easily tool where you can bring and deploy your application with SGX support through Marketplace. So we present the specific application which already supported SGX in virtual instances, bare metal, or in your Kubernetes cluster also. And how Agregion works and build their application in the G-Core Labs infrastructure and cloud. So you can hear and see in our YouTube channel. Thank you very much for your attention. I hope so it will be very useful for you, and we are waiting for your questions. And if you need help with infrastructure or how to develop your application with SGX, so please feel free to ask us, and we will help you to deliver and grow your business. Thank you very much.
Seva, thank you very much. It was very interesting and practical, and I'm sure that this information will help our listeners to make a proper decision while choosing the best services with Intel SGX. And again, I'd like to remind you to ask your questions in the chat. So our next speaker is Professor Christoph Fetzer. He's Chief Operations Officer at Scontain. Hello, Christoph.
Hello.
Hello.
Happy to be here.
Yeah.
I hope you see my presentation, and I have the pleasure to talk about how to use SGX and how to simplify the usage of SGX with our Scontain platform. And so you have seen the previous presentations that SGX really gives you some new features that allows you to encrypt the memory, to protect the data as well as the code of your application. And what we provide and what I will present today is how can we actually use our platform to simplify running your application in this encrypted part of the memory, which is called an enclave. So let me go to the next slide. So you have seen a similar picture already in the slide deck of Marcus. And what we focus on is on applications. So we want to make sure that the code as well as the data of the application is protected. And why is that so important these days? Because these days we want to outsource most of the functionality. So I, as a service provider, want to focus on my application, and I want to protect the data as well as my own code. And I want to delegate most of the work to some managed Kubernetes clusters, some also bare metal infrastructure provider. So there might be different ways what I want to outsource, but in principle, these days I want to delegate as much as possible because that is much more cost effective and much more convenient. I can focus on my applications. And of course, then I have these days the problem that whoever I outsource it to might look into my data and my code. Also, there might be lots of potential vulnerability. So there might be adversaries that take care of vulnerabilities in the operating system, the virtual machine, even in the CPU. There might be some vulnerabilities known in the CPU. And so what we want to do with confidential computing, and in particular Intel SGX, is to encrypt all the data and code while it is in the memory. And so therefore we want to have encryption in use, but we also need to have encryption in flight. So we have to make sure all the data that we communicate between our different service instances are encrypted, as well as the data that is on disks must also be encrypted. And we cannot delegate that encryption actually to the operating system because we don't trust the operating system, because it might be outsourced, the management might be outsourced to somebody else. And so therefore we have to make sure that our application can perform all that encryption in flight, at rest, in use, but we don't want to have more work for our developers. So the developers should actually, or ideally, not see that there is an encryption going on. So therefore, what we provide you with is that you take your cloud native application, so you have a containerized application, so you build your container image, and the Scontain platform provides you one way of transforming that container image into a confidential container image such that the application or all your services that you use in your application are encrypted, so run in Intel SGX enclave, so encrypted memory parts. All the data is automatically encrypted that goes to disk, as well as all the data that is sent via the network. In case you have not done the encryption, we can also transparently encrypt that. So we support some confidential service meshes to encrypt all the data that is in transit, as well as at rest, as well as in use. And you do that in one step. And I want to zoom into that important piece right now, because you, of course, when you outsource all your services, you don't want to have suddenly new work that you have to do. So therefore, the idea is that you automatically transfer your service from being a native service and you convert it into a service that runs inside of Intel SGX without you having to change your source code, without actually having to change your build process. Because what you need to do is just you build your normal native container image and then you can transform it. And so to show that, so here on this slide, all the software and hardware on the outside of your service cannot look into your service, doesn't see your code, doesn't see your data, and your service can communicate in a secure fashion to other services. But you can even, at least using a Scontain, you can also firewall it so that the service doesn't talk to other entities, maybe outside of your application. So you can also protect or make sure that the service doesn't communicate, is firewalled. And I have a little animation in a later slide that shows why that might be useful. So, but first, how can we transform an existing service, so existing container image, into a confidential one? And so what we provide in the next release of the Scontain platform, and that we also will provide for G-Core Labs, is that you build your application using typically multiple services that are deployed with a container image, and the container image you might build with Docker build, and you have one more stage in your continuous integration pipeline where you have something that we call Scontain build that takes your native container image, encrypts everything, makes sure that your service now automatically runs inside of a SGX enclave, and then you can run it like a normal application. During development, you might use Docker run. In production, you would, of course, use something like Kubernetes. So you use the managed Kubernetes of G-Core Labs and run your application inside of SGX, but you use the tools that you're used to. So you use just all the standard Kubernetes tools to deploy it. And so for that transformation, so what do you have to do? You take your native image that you have with Docker build, for example. You take something that we call a Scontain file, where you describe what you want to do. You say, okay, I have a certain native image. You see a little example on the bottom. and I want to create a new one, and I might have to say also which service I want to run inside of our enclave. There are more arguments that you can give, but this is a minimal example. So you describe what image you want to convert into a confidential image. So all the files are encrypted. Your service runs inside of a SGX enclave. So you have a protection at rest and in use. And if you also switch on automatic TLS connection, then also in transit. So this simplifies your thing. Of course, you will say, okay, during production, I have a little bit more things to do. So in production, when I use Kubernetes, I have to have also a way to tell Kubernetes that it should start my container images. So when you do a SCON build, we also create some Helm charts for you. So in case you know Kubernetes, there are Helm charts. That is a deployment manager for your container images, and that we can automatically create Helm charts for you. And we can also, in case some people don't like Kubernetes Helm, we can also have Kubernetes manifest generate for you. We generate this confidential container image. You just push that, and we can push that for you into arbitrary container registry. So you can use it you can use any Docker compatible container registry. And what we also have, what is important, but which I don't zoom into, is a policy. That policy describes how does my application look like, and we generate that for you. The policy says, okay, here my service has a certain hash value, so it has a certain binary, and we make sure that this binary is started in the enclave. So not that there is some person in the middle that changes your binary to leak your data. So that you have to avoid. And Intel SGX is fantastic in the sense that it allows us to check that our code is running on a remote host, and we describe what we expect in our code using a policy, and that we generate for you too. And we manage that policy for you inside of Intel SGX enclaves, of course. Okay, so let me zoom out again. So this was deep dive, and now what we do when your application starts. So you took your native container image, you transformed it into a confidential container image. Now your service runs inside an Intel SGX, inside a managed Kubernetes cluster, and then you deploy your application with, say, Helm or with just manifest of Kubernetes. And so there, when your service starts, we make sure that your Intel CPU is up to date. So the up-to-date firmware has fresh CPU hardware, and that is important. There were already in the chat some questions of what happens when you have vulnerability. So the great thing of Intel SGX is you can make sure that the firmware is up to date. You detect any security advisories that were out there, and you can make sure that the firmware is up to date. So you actually take care of potential vulnerabilities, and there Intel SGX really shines so that you can take care of all the vulnerabilities, because you can attest that you have the up-to-date microcode in the CPU. And the same is true for the software, because one important part of taking care of vulnerabilities is cyber hygiene. So you have to make sure that you run this up-to-date software. And there again, Intel SGX shines because you can attest what service code is running, and then you verify with your policy that this is the up-to-date software. So you don't run any out-of-date software. And what we do, we also make sure that your file system is in the right state, so there has not been a rollback of your file system. And we actually also provide, after that attestation, you with keys. So we can generate symmetric keys, public-private keys. We can even generate certificates. And that is important because these days it's really difficult to set up all these TLS connections. And typically, your private and public keys are in the file system, so they are visible. And then you have the problem, how can I roll these keys? And what we do with this security policies, you can roll the keys, so you generate the keys inside of enclaves. Nobody knows it, no admin will ever know that. And so this is also a great advantage that you can attest, making sure that the service is up to date, and then you inject, with our framework at least, all the keys into your application, and all the keys are just in the file system, and it looks to your service like, oh, they are just sitting there, and you just read them like a normal file. And we have also support for transparency, which is very important in regulated applications. So all the policy changes, all the starts of your application, all the certificates that are generated, you can actually log if you want to. So you have a log of all these changes, and you can store them in a ledger. So this is not a blockchain ledger, but a secure ledger similar to Google's Trillion. So where you have cryptographically, you change all the entries to make sure that you see, or you would detect if there would be a gap. Okay, so we support protecting your data and code at rest, in flight, in use, and also ensuring trust by attesting the software before we provision secrets. And you can also verify all the security policy and the updates using that ledger. Performance of the Ice Lake CPUs is really great. So they're like in TensorFlow Lite. So if you do classification, the performance is really like native performance, sometimes even better, sometimes a little worse, but it is close to native performance. And what I want to do in the last 2 minutes that I have in my talk, hopefully, or actually I'm not sure, I'm running out of time here, is that what I want to say that we can also protect the Python code. So if you have Python code, you can actually encrypt that Python code, or Java code, you can encrypt it, and you can make sure that this code is protected. So sometimes you have a code that needs to be protected from being visible by others. I have also a little screencast where we can show, or where we show we can have collaboration between or have services from different collaborators, and we can actually protect our secrets from them. I have a screencast here that you can see on our website, but let me skip that because I see that I'm out of time. Next steps, if you want to try this, you can register for a free account. So we have a community edition that you can try out. We have some documentation online that you can read. We have examples that you can look at. There are multiple. If you need any help with transforming your application, we can help you with that too. So I'm happy to get questions, send me email, or ask questions in the chat right now. That's it. Thank you very much.
Yeah, thank you very much, Professor Fetzer. It was a brilliant presentation, and seeing that you have a really good tool and you are dealing with big things. Thank you very much.
Thanks.
Yeah, looks like we are ready to move on the next section, Fireside Chat with our speakers. Let's us all come together. Yeah, and we are together. Hello, guys. Let me check question from Fireside Chat. Yeah, I see the first question was to Dr. Lieberrecht.
Yeah.
You answered it, Marcus, but let's discuss it once again. You mentioned that SGX to be most battle-tested hardware-based TAE for the data center. Could you tell us more about the challenges it faced?
Yeah. So as I mentioned in the answer there, SGX is by now on the market for some years, and has it was introduced originally with client PCs before it moved to the servers, and it made some pretty drastic claims like we did today about the security it offers. And surely enough, no security researcher can let that go unnoticed and unchallenged, really. And so SGX was scrutinized quite a bit, quite heavily. There's lots of papers about it. Also, several papers finding weaknesses. Well, that's the nature of complex engineering, that you will find in security technologies security weaknesses. And so we weren't actually anticipating that. And so we built in some mechanisms to update the business logic of SGX over time and be able to or to have that functionality, the sort of a built-in security life cycle within SGX to make it possible to iron out certain difficulties. And naturally, there's been some research into side channels as well. So side channels for which SGX was not designed as a protective measure, such as a power regulator side channels. That was something, and that is something that you just have to clarify. That's not the threat model we're operating after, and therefore it is battle tested in the sense that those weaknesses that were part of its security model, its threat model, those have been ironed out, and all of that goodness you will find in the latest generation of the Xeon Scalable processor in that implementation.
Yeah, thank you very much. One more question to you. Yashika Verma, she was asking you, she asked, I want to ask about the vision behind increasing EPC size in Intel SGX. And as I assume, increasing EPC size will increase other overheads as well.
Yeah, I think this is a bit of a slight misconception. The EPC size is the amount that you can maximum allocate for the secure enclaves, and by making them bigger, you actually make it easier for whole applications to fit in, and therefore make it less likely that you have to enter and exit the enclaves, which would cost time. You have to realize that. So fitting applications completely within an enclave actually makes things faster in SGX. And also just to follow up from that, fixed size, EPC size or not, it is fixed in the sense that a cloud provider provisions it at boot time. And so there's a maximum of EPC size available for all of the services running on that machine. But per tenant, it's totally configurable, and it depends on how the service is built up as to how much you see as a tenant and what you get offered.
Thank you. The next question is for Seva. Question is, G-Core has already chosen Intel SGX technology. What were the main reasons for this choice? Seva?
Yeah, of course. Yeah, thank you very much for the question. So, of course, we see the big potential in this technology from the G-Core side, and of course, Intel provide the new technology to secure the data. And one of the big questions from the end customer, especially enterprise customer, so how I can store my sensitive data in the public clouds, in the public cloud provider as well. Yeah, so in our case, we can complete all of the three types of encryption: data at rest, data in transfer, and data in use. Yeah, and with Intel SGX, we provide the last one. So this is the big point when we discuss with the customer and why customer choose us when they would like to store data or use the public cloud in specific regions and provide the secure store of their data and use this data for the end application. So I think so we can say that, so on-prem clouds and public clouds, so we can provide the same security option in the public cloud also. So this is why we choose this technology.
Reasonable. And a question from Nastya. Seva, what effects from SGX do you see already? What about customers' feedback?
Yeah, of course. So how I said in the previous question, so the main requirement from the end customers to store and use data with additional protection. Yeah, so we have a lot of positive feedback around our technology, especially when we can provide the virtual instances with SGX enable option on demand. So this is the huge option. The second feedback from our customers, so we can provide these kind of flavors around the globe. Yeah, so in the, if I can say that, exotic regions, yeah, in the specific region where other providers cannot provide this technology. So, and this is any kind of industries. I mean, so for example, retail, fintech, where a lot of sensitive data, and they would like to use and protect this data in the public cloud. So yeah, it's cool. It's a new niche for cloud service providers, and we are happy that our customers are happy.
Okay. Thank you. The question is for Christoph from Sovik. Hi, Christoph. Can you please tell a bit more how the Scontain framework can help to protect the Python code? Do you mean building a secure container and then encrypt the code, or something else?
Okay, that's a good question. So say you have your container image, native container image that contains your Python engines, typically the C engine, as well as your Python code. What we do in the Scontain build is we take your native code, we convert it into a confidential image. So all the Python code is encrypted, and the Python engine automatically runs inside of a SGX enclave. So we just convert that C engine, so the Python engine, into a confidential one that runs inside of SGX enclave. And only after that engine gets attested and we make sure that all the files in the container image are the ones that you put there, because therefore we have this policy, then we kind of then Python sees all that files unencrypted and can execute your Python code. And we see applications for that in the context, for example, machine learning. Often machine learning code is Python code. There's lots of intellectual property in this Python code. And what you can do with the Scontain platform is you convert your Python code that is containerized into a confidential container, and then everything is encrypted, not only your data, but also your Python code. And that also works for other scripted languages. So we also support JavaScript. So if you use JavaScript or if you used Java, the jar files, they are pre-compiled, but often they are really easy to reverse engineer. So from that perspective, you can also protect the IP that is in your code that is easy to reverse engineer it right now. And if you want to protect that, you can put that completely encrypted, and only inside of the encrypted memory, it will be decrypted. That is also cool for security policy or security, because you can randomize your code, and then if there would be vulnerabilities in your code, which sometimes exist if you use open source, then you can randomize that, and we actually do that, support that, so that it's really difficult for adversaries to find the vulnerabilities in your services and code. So the Intel SGX really gives you lots of benefits to protect your code and data.
Thank you very much. One more question. Your company is most responsible for integration with end customer platforms and applications. What are the most popular applications with SGX in your experience?
So there's, for once, machine learning is popular. So TensorFlow, for example, so people want to learn from data, and the data has to be encrypted. So we are in multiple projects with companies where they have data that needs to be protected. They want to do that in a public cloud. Right now it's mostly in private data centers, and they have to protect that, so the data. And so they want to move that out of their own data center into public clouds to make sure that the data doesn't leak. They can use Intel SGX and the encrypted data to make sure that only their code can access that data. This is one use case. The other one is if you have multiple partners that work together. Say you have a set of companies that work together and they have a workflow. You can actually move that workflow now into the cloud. You can connect them together confidentially. And even if you run my applications or my services, or my partners run them, my partners cannot look into my data. They cannot reverse engineer my code. And so I can protect my IP, but they can also protect their IP in the sense that I cannot leak their data. So I skipped this one animation where there's a really nice use case, multiple partners, multiple companies, they can work together, have something to have a common service, but they still can protect their IP. And that is really nice to use SGX for that.
Okay, thank you. One more question to each speaker, and I see that we are running out of time. Question for Dr. Markus. What industries demonstrate the highest attack surface and need more protection? Short answer, short question.
The highest, some of the most critical pieces of data that we see is personal information, and therefore wherever personal information is being used, this is really often enough a strong case for trusted execution environments, for confidential computing, and consequently for SGX.
Thank you, thank you. Seva, what do you think? Would SGX be a widespread security tool? What are the criteria for popularization?
Yeah, I think so. Our today's webinar, one of the criteria, of course. Yeah, so it's one of the important parts to provide the full information how you can use SGX and how you can implement the SGX to your application in Scontain, provide the tooling to easily develop and integrate with Intel SGX option. And of course, I think so the community webinars and provide the information for the new developers how you can use and protect your data. I think so it's one of the way how we can provide that. And I would say so today's webinar is one of the way. And I'm very happy to share this knowledge for everyone.
Okay, let's rock it. Show must go on. Okay, and I think that it will be the last question to Professor Fetzer from chat box from Eduardo. Could you please give some details on how the ledger could aid on transparency? What kind of information would be persisted on it? Of instance, and how could this favor some auditing process?
Okay, so when you attest a service, you expect a certain hash value of the code, and sometimes you have to update the software, and so therefore you also have to allow new versions of the software. With the ledger, you can make sure that you see all the changes in the security policy. You can go back and see, okay, what were the past version of the application that we are running, and that allows you to see that, or to prove that there was never any service that actually gotten access that had a leak, or that was some that was only temporary there to access the data. So you can see what service we are running. You can also put in like the Google Trillions, all the certificates that were generated. So this is important to make sure when you accept certificates that they were actually generated in a certain context. And you could also see when your services were started. So you have a track record of all services. And this gives you a very good audit facility, because you can see what happened over the time, because the data that is in disk This is the result of kind of your whole history of execution, and that ledger allows you to verify that all the data that was in there was always protected by your policies.
So thank you very much, guys. Thank you all for your questions and for your answers. This was the last question, and the official part of our webinar is over. And Dr. Markus, Vsevolod, and Professor Christoph, see you later. And thank you all for coming today. We definitely will take our engaging discussion to a next level in upcoming webinars. Thank you, guys.
Yeah,
Bye-bye.
thanks.
Thank you.
Bye.
Bye-bye.
Thank you. Bye-bye.